In this film, we will look at the final stage of our journey, solution. We will summarise everything we've achieved and use it to obtain our goals. Let's start with an example. Have a look at that bridge up there. Can you jump high enough to get up there? The answer is no. But can we come up with an immediate solution? Remember, what we want to do is to get up there. So we could take the stairs, but we didn't think of that because I used the word jump instead of the word get. Whereas if we use the word get, which is a more neutral word, instead of the word jump, we instantly remember that we can take the stairs. An inventor can use this system and step-by-step process to get to the solution. Ooh, made it! Our series of films is dedicated to problem solving, to finding wise, long-term and sustainable solutions which are not trivial. Our previous films have already shown us how to undertake the preparation needed to find the solution to any problem. First of all, we must formulate our ideal final result. We must coin our dream to be as precise and detailed as possible. If we miss out this essential step, then we may turn in the wrong direction. The question we need to ask is this: what do I want and what do I actually need? Is it an object, a function, perhaps a service? Is it the result of a function? Or is it perhaps even the impression of a result? Possibly, we may even enjoy the process along the way. Let's have a look at an example. I'd like to have fish for dinner. So I can either go to the supermarket and buy a pre-cooked, pre-packed fish, or I could catch one myself. Now, what it's important to consider is whether I want to eat the fish for dinner or whether I would rather have the process of fishing, whether that's more important to me than actually the meal. If the latter is the case, then of course the obvious answer is to sit here and fish. And in fact, if I sit here all day long and don't catch anything, well, I wouldn't consider it a failure. So in this instance, it's the process itself which is the ideal final result.
So we both know this here's a 6, yeah?
What are you talking about? This is clearly a 9. I'd like to say it's a very well-proportioned and beautiful-looking 9, but clearly...
When we discuss the subject matter, if we are in different context, we will never be able to understand each other and our problem will never be solved.
First of all, we should be aware whether the problem has already been solved. Otherwise, we will inevitably reinvent the wheel.
Look at what I just invented.
What about this? Resources are often available and sometimes even free, so we need to make a full catalogue of the resources we have. In many cases, the biggest obstacle may be the source for the solution. Remember the hourglass? Gravity won't allow the sand to travel upwards and therefore appears as our main obstacle. However, this is only the case when the sand is in air, because the sand is heavier than the air. But if the granules are placed in a liquid heavier than them, the liquid will travel downwards due to gravity, pushing the granules up. Therefore, the orange granules appear to be defying gravity. Very often, we can obtain the perfect solutions in the previous stages of the course by careful analysis and diagnostics of our problem. But if the problem persists, we have the set of TRIZ tools which will provide us with the most relevant and helpful solutions. Probably the best-known problem-solving tool is called 40 Inventive Principles. We know that the English alphabet contains 26 characters, Russian 33. An alphabet of invention consists of 40 letters, 40 principles. From a small number of letters, we can create millions of words. From those words, we make sentences, and those sentences form the world's literature. In the same manner, a whole host of solutions can be formed from the 40 inventive principles.
At this stage, we need to develop the conditions for our ideal final result. You can create such conditions using the following procedures. Using an obstacle as a resource enables us to have a win-win solution using 40 inventive principles. To find the right principle, you need to look into the contradiction matrix. The features we want to improve are presented in the rows of the table. The features that create obstacles for improvement are presented in the columns of the table. On the crossing cells of the table, we have the recommended inventive principles for us to follow. All the figures you see on the display in the chosen cell represent recommended inventive principles to solve your problems.
Hi, Henry.
Hello.
I hear you're inventing something incredible.
I am. I've just invented a super solvent. It will dissolve anything.
But hang on, you're going to have a problem. If it dissolves anything, what sort of container are you going to store it in? Let's have a look at the contradiction matrix to see if it can help solve Henry's problem.
We are going to stop the destruction of a container, improving loss of substance. But Henry's supersolvent is harmful for any container, so object-generated harmful factor is our obstacle. TRIZ matrix recommends the following principles: preliminary action, segmentation, discarding recovering, pneumatics, and hydraulics. Let's apply those principles to modify Henry's supersolvent without affecting its super abilities to dissolve everything. Henry can segment the solvent into two inactive parts and store them separately in advance. If he puts these two components together, he will get the supersolvent properties in the right place and at the right time. He just used the principle of segmentation and preliminary action. Inventive principle number 34 suggests that he is using rejecting, discarding recovering, and regenerating principles. Henry could make a container out of a substance that, after dissolving, automatically switches to the recovering process. However, this may not be feasible with current technology.
Very often we have conflicting requirements of the same object. We need it to be both short and long. For example, this ruler. Or this telescopic pointer. Or a measuring tape. Perhaps we also need it to be both cold and hot. Definitely hot. Maybe we even need it to be both present and absent. To resolve these contradictions, we need to follow two basic rules called separation principles. Rule 1. If we need contradicting requirements in the same place, we can separate them in time. We don't let them happen simultaneously. And rule number 2, if we need contradicting requirements at the same time, we can separate them in space. For example, CCTV footage can be recorded if a security guard is either present or absent. The footage is still being recorded, whether there is someone there to monitor it now or to watch the replay later on. In the process of problem solving, we need to bear in mind the following 4 points.
Point 1. In order to understand the problem, we need to target the ideal final result. We need to decide whether we're looking for the function, a result of the function, or maybe just the impression of the result. Point 2. All problems already contain their solutions. The main obstacle is also your main resource. Investigate the properties of an obstacle and see how you can use them for your benefit. Point 3. Shift between the contexts to find the solution. Point 4. If you come up with too many solutions, this means your problem definition is too vague. Go back to the initial stage of your problem definition and start again. There are more methods to generate solutions in TRIZ, such as functional analysis, resources checklist templates, inventive principles and standards, TRIZ contradiction matrix, nature-inspired solution generator, SU field analysis, methods for business and technology forecasts, laws and trends of technological evolution, sabotage analysis, size, time, cost, smart little people, focal objects, inversion and aggravation, and box for talented thinking. You can find out about how to use these methods to make inventions from our TRIZ courses and workshops. Remember, a more detailed explanation of tools for invention, as well as their relationship to each other, can be found in your course literature.